scientists. It's Jessica Power, one of the science curriculum coordinators at Kansas City Public Schools. Scientists, we've got some interesting things today, and we're going to talk about plants. Now, plants are all around us. There are trees, there's grass, there's flowers. Even when you go to the grocery store, fruits and vegetables come from plants. So we're going to take a look at plant parts today and focus on what those parts do. Now, even though plants look very different, there's very different kinds of plants, all plants have similar parts. Now, those parts might look slightly different. A oak tree leaf looks very different from a lily leaf, and vice versa. So we've got a plant here today that we're going to take a look at. But first, before we get to our plant, I want to go over what those plant parts are. Okay? So, scientists, the parts of a plant are on the chart right here for us. First and foremost, I'm going to start with the bottom of the plant and work my way up. Okay? Now, below the ground or below the dirt where plants are, there are parts of a plant called roots. And those roots, as you can see, kind of branch out. There's usually one large root that comes down from the stem of the plant. And then there's roots that branch out. Now the job, or we call that the function in science, the job of the roots is to keep the plant in the ground so that it's safe and doesn't come flying out. And it also is to absorb water and nutrients. Now, when we eat food, scientists, we are eating nutrients. We're getting calcium, we're getting vitamins, we're getting protein, carbohydrates. We are getting things, vitamins and minerals that our body needs to stay alive. Well, plants don't necessarily have mouths and they don't eat food on their own, but plants make their own food. So a plant's roots help to absorb water and nutrients, things like vitamins and minerals like the plants need to survive. Now the water comes up through the roots and then it goes up through the stem. Now the stem of a plant, scientists, is to support the plant. It keeps the plant upright. You can see in my plant over here, this flower, how the stem is going up. This stem is helping keep the flower up in the air. So it provides support. It gives it its structure or shape. And it also moves water through the plant. Now my plant needs a little bit of water, which is actually why we're using it today to learn about it. But if the plant needs water really bad, you start to see that stems start to droop and they start to fall over. And then once you give the water to the plant and the roots absorb that water, the water goes up through the plant and the stem stands back up. So our roots are going to bring in water and nutrients to the plant, keep the plant rooted in the ground or in the pot. Then we have our stem. Our stem is going to provide support, so it gives that plant support to stand up tall, and it's going to move water through the plant as well. Now attached to the stem or at the base of the plant are leaves. Leaves help to make food for the plant. A plant is really unique. I mentioned that plants don't really have mouths. They don't eat food like we do. Plants make their own food. And the leaves help them to make that food. The main job of a leaf is to absorb sunlight. So we bring the energy from the sun into the plant. And it's also to absorb carbon dioxide, which comes from the air around us. We'll get to that way later, okay? So leaves are going to help the plant make food. Now going up the stem past the leaves, we have two parts left. We have the flower and the petals, just like my flower has white petals right here. And those petals are going to attract insects or animals. And attract means it just brings the insects or animals to the flower. Have you ever seen a bee that comes over and it kind of sits in the center of a flower? Well, it picks that flower based on its petals. It likes its petals and it draws the bee's attention, or an animal. Sometimes birds come over to flowers, things like that. Now in the very center of the flower, the petals, are a bunch of seeds. Now seeds are what grow new plants. So in the very middle of my flower, I have some seeds. And if I were to take these seeds, I could plant those and grow a new Gerber daisy. That's what this plant is, okay? So let's go through these plant parts one more time because then I'm gonna show you on the real plant. Starting from the bottom, we have our roots, and those roots are gonna keep the plant in the ground, right? It's gonna keep that plant stable so it doesn't come out of the ground. If you've ever seen tree roots before, tree roots are really deep and spread out really far. The bigger the tree, the bigger the roots. So the roots are gonna keep the plant in the ground and absorb water and nutrients. When you water a plant, scientists, you don't water the leaves. The leaves aren't gonna take in the water. You water at the base of the plant or where the dirt or soil is. Once that water is absorbed into the roots, it's gonna come up through the stem. So the stem is gonna move water throughout the plant so the whole plant has water. And it's also gonna support the plant, right? It's gonna keep those flowers held up high, those leaves as well, like on this plant. Moving to the top, we have our flowers, and those flowers are made of petals, and petals look very different. A Gerber daisy petal looks very different from a lily, which looks really different from a rose, which looks really different from a hibiscus, right? There's different kinds of petals based on the plant. And then in the center of those petals, we find seeds. And those seeds are what we can disperse, right? So we can take the seed from a flower, or insects will take those seeds, or different animals will take those seeds, and they'll spread them throughout, and that's what gives us new plants in different places. So scientists, let's take a look at this plant. So first and foremost, this is what's called a Gerber daisy. It's a summer plant. It likes heat and it likes sunshine. And unfortunately, the temperatures are starting to get cool. And this poor Gerber daisy doesn't like that. So, for the sake of science today, we're gonna take the Gerber daisy out of the pot, out of the dirt, and we're gonna take a look at its roots, we're gonna take a look at the leaves, we're gonna take a look at the stems and the flowers, okay? Now I mentioned earlier, this poor Gerber daisy needs some water, okay? So, first things first, let's take a look at the flowers. Let's go top to bottom of this plant this time, okay? Now, there's two flowers currently on it, and you can see one is a newer flower. This Gerber daisy is a newer flower than this one. Now, these brown spots on the Gerber daisy are just from the sun. So they've just gotten a little bit too much sun exposure, and it starts to turn brown. Now, you notice as flowers start to fade away, or they start to die, they start to fall off. So with this Gerber daisy, some of its petals have already fallen off, but you'll see the petals just come off, nice and easy. And then eventually, and I left this guy on here for us to see, this is what a Gerber daisy's seed or center looks like with no petals. So a Gerber daisy, if you can see over here at the bottom of it, it's kind of like a bowl. It creates like kind of like a cone shape. But this is where those seeds would come off from the center of the flower and would create new ones. Now this center is no longer living. You can see it's not functioning anymore, okay? But these flowers will eventually look like this. And then you can see, if I can carefully pull them off, yes, these are those seeds that I had talked about. So these seeds get carried by different animals or insects, and if they land and they start to grow, they'll create more Gerber daisies. Okay, now a Gerber daisy doesn't necessarily have leaves that come from the stem like this plant. A Gerber daisy's leaves grow from the bottom at the base, so where the stem of the flower connects with the root, that's where the Gerber daisy's leaves grow. And as you can see, this Gerber daisy has tons of leaves. So what we're gonna do is we're gonna take this Gerber daisy out of the dirt. Dig around a little bit to loosen it up. wind's just wanting to bring the whole thing out. So let's move it over. I have a garbage bag below me, so that way the dirt can spill over on the garbage bag. And these roots are really in there, you guys. Oh my goodness gracious. Just gonna make a mess. I'm gonna tip the pot over so the dirt goes on. We're almost there, scientists. We're almost there. Okay, I see a root. Try not to get dirt everywhere. So scientists, this is what's called a root ball. And it's the base of the plant. Now this Gerber daisy grew really well this summer, okay? So it created lots of flowers, was very healthy. So this is a root ball. And the root ball just has tons and tons of roots. As the daisy grew, the roots grow. So here's our Gerber daisy. And here's our root ball, okay? So this is what our plant looks like. Now you can see, I'm gonna hold the Gerber daisy by its leaves. Do you see these strings? This is a really good picture. See these? They kind of look like straws. These are the roots of the plant. So scientists, these are what, there's a good one. These are what's absorbing that water and those nutrients to make the plant healthy and grow really well. Now scientists, when I planted this Gerber daisy in this pot, the leaves and the flowers were only about this big. And now you see how big the roots got. So as the plant grows, the roots grow, right? And the bigger the plant, the bigger the roots, the more water and nutrients that plant needs. So our job today, scientists, was to learn about the parts of a plant. And I showed you my Gerber daisy. Remember, plants have roots, they have stems, leaves, flowers, and seeds. So when you're out in your community, or maybe you have plants at home, go take a look at them. You might want to ask before you pull the plant out of the pot or pull the plant out of the ground. Not everybody likes their plants being unplanted. Take a look at the roots if you can, take a look at the leaves, take a look at the flowers, and as a scientist, make observations. How do the leaves of your plants that you find compare to other plants? How do the roots and the leaves of the plants you find compare to my Gerber daisy? That's what's interesting about science, scientists, is that even though these are all plants, they're still very different, but they still have the same parts. Scientists, I will see you back here next week and we'll talk more about plants. Have a great day.
Kindergarten is great at Kansas City Public Schools.
I know they have really good teachers. I know this is a great school.
They teach them stuff that I thought my kids would never be able to know at the age of 5.
Since deciding to send our kiddos to a neighborhood school, we've become even more of a part of our community.
Now is the time to enroll your future kindergartner for the new school year. Visit enrollkc.org today.
The desire to create lives within each of us. From Grammy-winning producers and musicians, to NBA stars, to Navy admirals and Medal of Honor recipients, to internationally renowned artists and beloved local muralists, Paseo graduates have been creating their own success, their own history, their own legacy since 1926. Now it's your time. Create your future at Paseo Academy of Fine and Performing Arts. Learn more at enrollkc.org/Paseo.
Hey scientists, it's me, Jessica Power from Kansas City Public Schools, one of the science curriculum coordinators. We're back today with more science, but guess what? We're not talking about life science this week. We've spent a lot of time in the last few weeks talking about life sciences and plants and animals. We're going to switch gears this week and talk about Earth and space science. Now here's what's fascinating about Earth and space science. There is still so much that we don't know about space. But we can't focus on what we don't know. Let's talk about things that we do know. So scientists, this week we're focusing on day and night. Now, I don't know if you've noticed, but currently the season's starting to change, and it's fall or autumn, and we've just had our autumn equinox. Now, something that's interesting about the autumn equinox is that you're going to start to notice that the amount of daylight during the day is starting to get shorter and shorter and shorter. And then we'll have daylight savings time, and it'll be off a little bit, and then we'll jump back into not having too much daylight. But scientists, before we can talk about the autumn equinox and before we can talk about why the daylight is starting to change and why it's shorter in the winter and fall and longer in the spring and summer, I need us to know why we have day and why we have night. And so we're going to focus on a few things today, scientists. We're going to focus on day, night, axis, and rotation. Those are our 4 keywords today. So I'm going to show you a really quick picture of Earth. Now, you might be familiar with Earth. What do you notice about Earth? You might notice that it's a globe, or looks like a circle in this book. You might notice that the continents are facing up and down, right? Up and down. You may notice that North Pole is all the way up here and South Pole is at the very bottom. But scientists, the Earth doesn't actually sit this way in space. So let's look at a globe. Now scientists, the Earth actually sits on what's called an axis, meaning that it has a tilt. So this is a globe. And you'll notice this red line that runs through the globe. That red line is called the equator. Now based on what I showed you in the book, you would think the Earth would sit like this. So the equator runs through evenly. But it doesn't. It actually sits on a tilt. Now scientists, we are focused today on the words day, night, axis, and rotation. The North Pole of Earth, that very center dot at the top, and the South Pole of Earth, where my little spinner's at the bottom, there's a straight imaginary line that runs through that. And that line is called the axis, and it runs through the very center. You'll see back here on the chart I've created for us today, the axis runs straight through the center of Earth. And as I mentioned, since the Earth sits on a tilt, it's not straight up and down, it's shifted. We'll talk more about tilt next week. For today, we're just focused on rotation, axis, day, and night. So the Earth has this axis point, right? And during the course of a 24-hour day, the Earth does this thing called rotating. Now scientists, to you, it probably looks like I'm just spinning a globe. And I am. A rotation or rotating is simply an object turning or spinning on an axis. So as you can see, the axis that runs through Earth is the point at which the Earth spins around. Now it takes the Earth about 24 hours to make a complete spin. So if I put my finger on Tanzania, right here in Africa, and I spin the globe around, one full rotation, back to where I started, that would be 24 hours. Well, it's actually like 23.93 hours, but we count it 24. So let me do that again. This time, let's pick Brazil in South America. Okay, my finger starting here. It's gonna make one full rotation back to where I started, and that's 24 hours. So in 24 hours here in Kansas City, we experience daytime and we experience nighttime. But this globe isn't helping me with day and night. So let's go back to our chart. So scientists, we get sunlight from the sun. as we know that, right? And that sunlight shines down, and we feel that and we experience that during the daytime. When we're experiencing daytime, that means that the Earth is directly shining light where we live. So you'll notice, scientists, that I actually shaded half of this globe darker and the other half I left blank. Now for our point of reference, I went ahead and made this North America and South America. So you can see that right now, and this is actually starting to be nighttime, if you see a little bit of like Florida and the East Coast, so this would be the evening for us, about sunset. The sun is shining on this half of the Earth, and when the sun is shining directly on half the Earth, that's daytime in that part of the world. Now let's flip to the other side. You'll notice that I've shaded it darker. You'll notice that the sun isn't directly shining light onto that part of the Earth. That's when we experience nighttime. So scientists, the Earth is constantly spinning. It's constantly rotating on its axis, as we showed with the globe. Spinning. As it spins, some parts experience daylight. So right now, for example, since there's light in front of me, we'll play this off. It's currently daylight in Africa and part of Europe and Asia. Daylight, daylight, daylight. Now as this Earth spins, now it becomes day in North America and South America, where Asia and Europe and Africa are experiencing nighttime. And it continues to rotate, right? We're hitting sunrise in Asia, sunrise in Europe, sunrise in Africa, daytime, daytime, daytime. Sun is starting to set in Asia, Europe, and Africa, and the sun is rising in North America, South America. And I keep forgetting about Australia. Sun is rising in Russia up here, China, Asia, Australia. It's a pattern, right? So scientists, again, when we're experiencing daylight on our half of the globe, the other half of the globe is experiencing nighttime. And that's really interesting, right? Now, I put a little reference here. So as the Earth rotates on its axis, one side faces the sun and experiences daylight. The other side doesn't face the sun and experiences nighttime. Now, scientists, you've probably noticed that the sun follows a specific pattern in the sky, and that's intentional. When we wake up, right, when it's sunrise, the sun's always gonna rise in the east and set in the west. And that's because of how the Earth is spinning on its axis. It's always gonna rise in the east and set in the west. Now you may notice during our different seasons, which we'll talk more about next week, that sometimes the sun appears to be higher in the sky in some seasons and then lower in the sky in some seasons. And we'll talk all about why that is next week. But for this week, we were focused on day, night, axis, and rotate. So to recap, let's recap this whole thing. First and foremost, the Earth spins on an axis, or it rotates. Now the axis is that imaginary line that runs from the North Pole straight through the globe to the South Pole. So here, where my finger's at, and here. That's our axis, Earth's axis. And the Earth spins on that axis. Now when the Earth is facing the sun, when the side of the Earth is facing the sun, we get daylight. When that part of the Earth is not facing the sun, we get nighttime. And scientists, do you remember how many hours it takes the Earth to do a full rotation? 24. Do you remember the specific number I said earlier? 23.93, but we round that up to 24. So 24 hours in a day, and that gives us our daytime and our nighttime. Now, scientists, there's a misconception. Misconception means that people think something that isn't necessarily correct. You may hear people say, it's day right? It's the day out. Technically, a day, scientists, is 24 hours. So the misconception is that a day is 24 hours, not just when the sun is shining, okay? So if you hear someone say, you know, what is the day like? That really just means what's it like outside during the daylight. Does that make sense? So there's 24 hours in a day. Part of those hours we spend in daylight, which is just how many hours we're getting direct sunlight, or when the sun is approaching in the east and setting in the west. And then the other part of the day we experience nighttime, when the sun is facing away from us. And when the sun is facing away from us, that means across the globe, other countries and other people, just like you and me, are experiencing the opposite. So if we're experiencing day, they're experiencing night. Daylight, they're experiencing night. And if we're experiencing night, they're experiencing daylight. So, scientists, as we move forward for next week, we're gonna start to talk about this word called revolve and revolution. And I don't want us to get confused with revolution and rotate. So again, rotate is to spin on an axis, right? That's an imaginary line that runs through something and it rotates. You and me, we can rotate. We pretend that there's a pole that runs through our head, down through our spine. We can rotate. We can spin. So, think about, as you're going through every day, maybe start to track. When does the sun rise and when does the sun set? How many hours of daylight are we getting right now? How many hours of night time are we getting right now? Not only will that help you to track the sun and see how much daylight we get, but that'll start to get you seeing some patterns as we move into next week and talk about seasons and talk about this word revolution. So scientists, keep track, not of hours in daylight, keep track of how many hours of nighttime we get. Should equal 24 or 23.93. And I'll see you next week.
I chose manual because it's challenging and fun and it can help me with college.
I chose manual because I wanted to get a jump start in my career with culinary arts.
I chose manual to acquire skills I'd use in real life.
I chose manual because I want to be an ER doctor and be an EMT is my first step.
Kickstart your future today at Manual Career and Technical Center. Manual is open for all 11th and 12th grade students in both Kansas and Missouri. Learn more today at enrollkc.org/manual or call 816-418-5200.
I love Southeast because of the culture, the band program, and restorative justice.
I love Southeast because of the academics, sports, and students.
I love Southeast because of the people, the energy, and the advanced classes.
It's not alike. I love Southeast because the students here at Southeast are full of potential and they believe in achieving anything.
We are Southeast.
Southeast.
We stand shoulder to shoulder.
Join the Southeast family. Enroll today.
Hi, I'm Erica Mabian, iSpark STEM Coordinator with Kansas City Public Schools, and this is STEM for grades 4 through 8. Today we're going to break down problems into smaller manageable steps, into sub-problems to facilitate a program development process. We have a project that we're going to be participating in today, so I'm really excited. So let's get started. Today, what you're going to need is a piece of paper to take down notes so that you could replicate this project at a later time. For the project, you're going to need a small bowl basin, or you could do it in your sink. You're going to need marbles or maybe 15 pennies or something small that you could use as a weight. And you're also going to need about a gallon of water to put in the basin and aluminum foil sheets. Regular aluminum foil, not the heavy duty. Let's take a quicker look into our lesson. Get ready to learn. Our criteria and constraints are as follows. Criteria and constraints. What do I mean by that? What I mean by criteria, when you start to do this project, there are certain things that you're going to want to think about. For one, our foil sheets are going to all need to be the same size. That way, if you replicate the project, you can see how it may be differentiated based on using the same size sheet and folding it in different ways. Next, the constraints. When you build your boat out of your aluminum foil, you need to know that it must hold the weight of the things that you choose. Say it's your 15 pennies or your marbles. Make sure that your boat that you construct will hold the weight of those without sinking. Next, let's think about the process. We use something called the design process when we are going to do projects or experiments. The first part of the project is to ask questions. What is the problem? Well, in this situation, the problem is we need to create a boat that can withstand the weight of the materials that we're going to use. Next, let's think about what are some possible solutions. Maybe you discuss this with your family, or you make a list of it in your head or on your paper. Finally, the questions you ask yourself are going to determine your step-by-step process that you're going to use in order to construct your boat. Let's look at step 2. Planning it out, your strategy. Let's think about your strategy. Well, the first thing in the design process is we create a sketch. Maybe you're going to use a thumbnail sketch, and that's just a quick sketch. It's just flat on your piece of paper, and you just get out the details roughly and not specifically about how you want to construct your boat. Next, imagine your prototype. Make a mental picture of it and consider how it will look like whenever you have it in the basin of water. At that point, you may want to make an isometric sketch. That means that you're going to do a 3D version of your sketch so that you can see the dimensions, the size, the width that you would like to construct your boat out of your aluminum foil. And finally, you're going to consider the criteria. Remember the criteria and constraints. That boat that you make is going to need to hold the weight of the items that you choose. And the purpose of your design is that you're going to make the boat. So let's keep going. Next, it's time to make your model. When you make your model, always consider those criteria and constraints and select your most appropriate design. That means that if you've chosen a thumbnail sketch or an isometric sketch, you want to use the one that's going to give you closest to the thing that you can replicate when you decide to build your prototype. Now, testing your prototype. That's when you finally get your boat that you've made with your foil and put it in your water so that you can see what happens. I would do this in phases. Set it in the water and then start to add your weights. Evaluate your design. Ask yourself questions based on what you see. Do you see air bubbles? Is it starting to sink instantly? Is water starting to seep in from sides to sides or front to back? And then finally, you're going to analyze what happens as a result of adding your weights inside your foil boat. And the last part is reflection. Reflection is where we get a chance to think about how smart we are getting from this type of activity. What changes would you make when your boat sank to the ground? Did it withstand the constraints? Did it hold your weight? How could you improve that boat the next time you do it? And how will you communicate your successes and your unsuccessful design process? So those are ways that you could go back and redo your boat and test it out again. This has been Erica Mabian with KCPS Homeroom. Let's start our project now. Let's get ready to make our prototype. So now we have our model, and this is based on my first isometric sketch. When I did my isometric sketch, I thought about the 3D model and how I wanted it to look. So I built up the sides, and some sides are shorter than the others, but I thought this would replicate what was in my sketch. So let's test it out. So I'm going to add about 5 marbles each time so that we can watch as I'm putting in the marbles to see when it floats and when it starts to sink. I'm evenly distributing the marbles across the whole base of my boat so that I can make sure that the weight is evenly distributed and it sinks. So when we get ready to test out our next boat, we were going to count our marbles and see how many were in there so that when we do it the second time, that we can make sure that those even out with the same amount of weight. So I'm going to pull those out. All right, now I have them all out, and I'm looking at my previous design, and when I get ready to make my second design, I'm going to do some changes. The first time I folded it down the middle, but I'm thinking that it may need to be a little bit more strong, so I'm going to decrease the size of my boat significantly by folding it an additional time. So this time, the base of my boat is going to be much smaller than it was initially, but the bottom is going to be significantly more strong to withstand the weight of those marbles. So hopefully, I will be able to get more marbles inside and it still will float. So let's take a look at the second prototype. The second prototype is different than the first one in a lot of different ways. It's about half the size, but the base of it is a lot more strong. So when I think about that, the constraints will be a little bit different for each boat. Next, we're ready to test it. Let's test out the second prototype. When you're watching, I want you to evaluate my design, just as you would your own when you do this experiment at home. Ask yourself questions about what you see now versus what you saw at the beginning, and then we can analyze those results. So here we go. I'm going to be sure to evenly distribute the marbles so that, it sank. So let's think about this. Did the new boat have enough reinforcements on the bottom? Were the sides high enough to withstand the weight of the marbles? So let's take a look at the difference. The sides are smaller here. They're a little bit longer here, but that didn't help my design. It did not withstand my constraint. So I was not able to put as many marbles in this boat as I was this first boat. And then how could I communicate that? So I would go back to my sketches, look at them, and see what I liked about the first one that was different than the second one, and I could reevaluate my design and come up with a third boat. Maybe you could have a contest at your house to find out who can make the best boat that it could hold the criteria and constraints, and just play around with it and have fun. If you find a design that you really like and have your experiment, you can tweet it out to us at KCPS or hashtag me at 312Mabian and tell us about your experiment and how you design your boat to match the criteria and constraints. Be sure to hashtag us at KCPS Homeroom. We love to hear about all the things that you were learning during this process of making a design. Have a great day.
Kindergarten is great at Kansas City Public Schools.
I know they have really good teachers. I know this is a great school.
They teach them stuff that I thought my kids would never be able to know at the age of 5.
Since deciding to send our kiddos to a neighborhood school, we've become even more of a part of our community.
Now is the time to enroll your future kindergartner for the new school year. Visit enrollkc.org today.
The desire to create lives within each of us, from Grammy-winning producers and musicians to NBA stars to Navy admirals and Medal of Honor recipients, to internationally renowned artists and beloved local muralists, Paseo graduates have been creating their own success, their own history, their own legacy since 1926. Now it's your time. Create your future at Paseo Academy of Fine and Performing Arts. Learn more at enrollkc.org/Paseo.
Good morning, ladies and gentlemen. It's Dr. Jones here. And as I told you before, we're going to pick up our conversation about cells and about atoms. And we're going to be talking about how we go from a single atom to a single cell. Now, as always, we start off with our standard. Now, again, just like before, we have our middle school standard and we have our high school standard. Now, in our middle school standard, remember we talked about specifically the functions of cells. Okay, so how does a cell carry on the characteristics of life? With the high school portion of this, we're going to be talking about the hierarchy of life, meaning how do we go from one cell to like a blue whale? All right, so let's first start with this first topic, or this first standard here that literally talks about cells being the smallest unit of life. Now, as we have here, atoms are the smallest unit of matter. And if you remember from before, matter is anything that has mass in grams and takes up space. So it's not or, but it's and. So again, when we're talking about matter, matter is anything that has mass and takes up space. Okay? So if we're looking at this, we said that mass is measured in grams and volume can be measured in liters. So we talked about all of that before. Now, when we talk about a cell is the smallest unit of life. Now, here's the thing. If you open up a dictionary, if you Google life, you're going to get a bunch of different definitions. For scientists, when we talk about life, we have to talk about the characteristics of what living things do that other non-living things don't do. And there's 7 characteristics. There's 7 things that all living things must do. And again, for those of you who are my middle school students, we went over this, but not specifically for a cell. So in this conversation, we're going to talk specifically about how a cell goes through all of these characteristics and is considered to be the smallest unit that can carry this on. All right? So let's start with the first one, organization. Now, when we talked about organization previously, I just said that think of organization as being like rules to the game, okay, or like how things happen. When we're talking about cells, organization really goes to, well, what atoms, since cells are matter, make up cells, okay? So if you're looking at it, all components or parts of a cell are made up of a combination of 4 macromolecules. Now, let me stop. Macro, large. Molecule, that would be something that has more than one atom. Think of it that way. So we're talking about these blocks, these units that have more than one atom, but they make up all these different components of a cell. So let's start with the first one. It's easy. Proteins, okay? And when we're looking at proteins, let me do this because I noticed I got a little something on my screen. There we go. Now, when we talk about proteins, understand that proteins are very complex molecules. They actually come in 4 varieties. You have a primary, or very simple protein. You have your secondary, which some people call a corkscrew or a pleated sheet. You have your tertiary, which was like the 3rd level, which is 3-dimensional, and then you have one that is called a quaternary, which would be like the 4th level. Okay, so you know, like if you're going up a flight of stairs, the 4th level is the most complex, the highest level. Okay, now in addition to proteins, we also have what's called lipids or fats. Now the thing about lipids is they come in a bunch of different varieties as well. But what you'll find is that they do different jobs. So when we talk about proteins, think of structure. Think of that proteins do a specific job. think of a lipid as storage, kind of like a bank. And a bank of what? A bank of energy. Okay? Now, the other energy molecule that we're familiar with are carbohydrates, which are sugars. So think of this as being the bank. Think of this as being like money in your pocket. Because you need carbohydrates for that ready, quick energy. Okay? I'm going to tell you, I have a sweet tooth. I like candy. I shouldn't, but I do. It's my weakness. And so what you'll find, just like, with anything, if you eat candy, it's going to send your levels of energy and sugar levels up. Once you burn it away, it'll go back down. One thing that I don't have a lot of is a lot of fat. So I tell people, you know what? I'm not going to be the guy that goes on Survivor. Skinny guys and muscular guys never make it through Survivor. If you watch the show, you will see every single season they don't make it. Why? First of all, they don't have the extra calories. And once things get real hard, they don't have the fat. It is what it is. Now, the last one, nucleic acids. You're familiar with DNA and RNA, right? Well, that's what this is. Now, yes, we have these 4 molecules. But you may say, well, where's the order? Here's where the order comes in. I picked these models because I wanted you to take very close or pay very close attention to the color scheme. Here's what I'm saying. If you're looking at this, what you'll find is that carbon atoms here are black, and all of these have some black or dark gray spheres. Hydrogen is white, okay, or light gray. Oxygen is red, and if you look at every single one of these, they have carbon, oxygen, hydrogen. Here's the other thing I want you to notice. Some of these have blue in them. Blue represents nitrogen. Some have orange, that's phosphorus, and one that you can't see but it is in here is sulfur, that'd be green. So what you find is that all cells have these 6 elements, okay? Carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur. All right? And together, they spell the word CHOMPS, which is very interesting why this is here, but I'll explain what CHOMPS stands for. C-H-O-N-P-S. Not chomps with an M, but chomps, like Chauncey. Okay? Something like that. All right. Now, let's talk about the next one. Growth and development. Now, it's not like you're going to have a small cell that's going to be a big cell, okay? Because cells don't like change size that way. But when we talk about growth and development in terms of a cell, what we're talking about is you could start out with a cell being one thing at a particular point in the cell cycle. So like stem cells. And then those can break up and become other types of cells. Okay. So these mesenchymal cells are cells that'll give you things like muscle tissue. These, which are your endoderm cells, give you things like lung tissue. And these are ectoderm cells. Think of these as being the ones that will give you like skin, things of that nature. Which is one reason why stem cells are so important. Because what you find is if you get a stem cell and expose it to the right kind of hormones, you can make whatever other cell you need in your body. Okay? So again, that's what is meant by growth and development in terms of cells. Energy production. Now, here's the thing. All living things have to process energy. And where do they get the energy from? Outside of the cell, or like its surrounding. Now, if you look at the mitochondria, the mitochondria actually takes sugar and breaks it up into giving you energy. Now, I want to say this. I know. So many of you have heard mitochondria is the powerhouse of the cell. Listen. If you hear somebody that says that a mitochondria is the powerhouse of the cell, I'm not saying to slap them, but if you do, it's understandable. Because it's not the powerhouse of the cell. No. The mitochondria is how cells convert sugar, the carbohydrate, into energy, which is actually a nucleic acid, ATP. We'll talk about that later. The other way that cells can process energy, not every cell, but certain cells, is by converting light energy into sugar molecules. Well, we know this as photosynthesis. Now, you may say, okay, well, where does that happen? That's chloroplast. So again, think of a cell, think of its organelles. It has an organelle dedicated to converting sugar into energy, and some cells have an organelle dedicated to convert light energy into chemical energy in the form of sugar. Okay? So, energy processing. Response to the environment. Now, here's the thing. There's a process called tonicity. Okay? And think of tonicity as just water availability. But there's a barrier in between. It's like this. You see how I'm dressed, looking good, you know what I'm saying? So, after like a day at work, sometimes at night, I don't go out to a club. So I get to the door, I see the doorman. Doorman sees me, I'm like, what's up? He said, what's up? What's the cover? $20. He looks at me, yeah, $20. Boom, go in, right? Then you have some of these knuckleheads wearing tennis shoes, pants sagging, just headbangers. Yeah, man, what's up? Look, I want to get in the club, what's going to be. And the man look at him like, sorry, sir, but no. What you talking about? Wait, no. And so what I'm saying is, sometimes you have a membrane that is semi-permeable, meaning it'll let some things through, but not others. So, when you're looking at cells, one of the semi-permeable membranes is the cell membrane. And what it'll allow to go through is water. So, depending on if you have water that is fresh, meaning you have no salts in them, water that has a lot of salts in them, or water that is comparable to the cell, depends on the movement of water into and out of the cell. That's tonicity. Okay. So we have hypertonic, hypotonic, and isotonic. Now, here's the thing. When you put a cell in, especially animal cell, different types of water, it will react to it. Because living things do that. Now, one thing about cells is that you have to be able to maintain homeostasis, the inside environment, which means you have to be able to regulate this. So what you find is, although that happens at the cell layer, the cell membrane, there are ways that the cell membrane regulates what goes in and goes out to make sure that I don't lose too much water or I don't take too much water on. So there are actual organelles that'll push or shunt water out. A lot of times it can happen through proteins, or bring nutrients in, also happening through proteins, as well as the membrane itself being semi-permeable to let certain things like water and air through. Okay? That's the regulation side of this. Reproduction. Now, understand that cells can reproduce one of two ways. Meiosis, mitosis. And meiosis is where, remember, you have one cell that becomes 4. That's the one for sexual reproduction. And then you have mitosis, where you have one cell becoming 2. That's kind of like the budding or the cloning that you'll see in bacteria. But again, cells, all of them, go through some form of this, one or the other, or sometimes both, depending on the type of cell. And then adaptation, okay? And so when we talk about adaptation, and I know it looks like I have another 6, but forgive me. We're talking about how the last universal common ancestor, meaning this is the cell that all other cells came from, actually adapted to become other organisms. Here's what I mean. If you think about it, from Luca, last universal common ancestor, you get bacteria, you get protists or protista, you get fungi, he's a fun guy, plant cells, and animal cells. So what you find is that cells go through all of these processes, which is why a cell is considered to be the smallest unit of life. Because things like viruses, they don't go through all of this, which is why a virus isn't alive. Now, the next time we meet, we're going to be talking specifically about how a single cell goes from being one single cell organism to a multi-cell organism like a blue whale. I will see you next time. Have a great day.
The desire to create lives within each of us. From Grammy-winning producers and musicians, to NBA stars, to Navy admirals and Medal of Honor recipients, to internationally renowned artists, and beloved local muralists, Paseo graduates have been creating their own success, their own history, their own legacy since 1926. Now it's your time. Create your future at Paseo Academy of Fine and Performing Arts. Learn more at enrollkc.org/Paseo.
I love Southeast because of the culture, the band program, and restorative justice.
I love Southeast because of the academics, sports, and students.
I love Southeast because of the people, the energy, and the advanced classes.
It's not alike. I love Southeast because the students here at Southeast are full of potential and they believe in achieving anything.
We are. Southeast. We stand. Shoulder to shoulder.
Join the Southeast family. Enroll today.
I chose manual because it's challenging and fun and it can help me with college.
I chose manual because I wanted to get a jump start in my career with culinary arts.
I chose manual to acquire skills I'd use in real life.
I chose manual because I want to be an ER doctor and being an EMT is my first step.
Kickstart your future today at Manual Career and Technical Center. Manual is open for all 11th and 12th grade students in both Kansas and Missouri. Learn more today at enrollkc.org/manual or call 816-418-5200.